Hello, everyone. So, we are Group 18 from SCR 531 course, and we have worked on creating a knowledge graph for our project named Crimeware. Here, we have built a React based web interface which helps in querying and helps in visualizing crime data for Los Angeles and Chicago cities. Uh, you can go to the web application.
Okay.
So, yeah, our application basically helps in enhancing public safety and other real world challenges because it gives us, contextual analysis of crime hotspots, crime trends, crime types, etc. So, for this project, we have taken uh, a few data from LA and Chicago from open data, and we have added columns. Basically, we have tried to combine two different databases and data sets, and for each city, we had different time frames. So we have kind of combined and made the time frame uniform from 2010 till present, and we have also manually merged a lot of columns and removed unnecessary data such that we have uh, a working CSV for our file for now. So we can actually get started with going through our application.
So I'll be explaining the first use case of our app, which is contextual analysis of crime hotspots. So these are basically the TTL files we have uploaded into the GraphDB. And for the first use case, let's go into it. You can also access the use cases from here. This is the header portion. So we have designed this UI using React. And this is a cluster-based heat map of crimes that are happened in Chicago, according to our data. So I'll just click some and just go into it. So this is, so once we can also see the description of the crime and location and latitude and longitude. So these are the basically the attributes which we have used to plot out these crime spots. And for the code for this, so this is the code, the React code, and here is the query that we have used for this use case, and I will run it for you in GraphDB also once. So yeah, I will just limit this to 1000 for faster run. So as you can see, this is the output of the query. We have latitude, longitude, location, and prime description. So now I would like to pass on to Kalyani to explain the second use case of the web application.
Yes, hello everyone. Can you just move to the main page?
Yeah.
Okay, so the second use case in our application is temporal analysis of crime trends. So basically, temporal analysis looks at crime patterns over time. Basically, in our application, we have considered the temporal analysis over the years. Can you click on view trends?
Yeah.
So here we can enter the crime type. So for example, if we check for theft, we can see over years from 2010 to 2024 what the crime trend has been. So basically the number of crime counts, and we can see over the years whether the crime has increased or decreased. This can help police to identify how the crimes are increasing, and they can also plan the resources according to these trends. Um, can you go to the code? Yeah, so this is our code for the use case, and this is our query. Yeah, so we are displaying the crime description and the year and the crime count based on the different relationships that we have created in our ontology. Yeah, I think here we'll have to change the year. Can you enter? No, can you enter SMW? Because this is on GraphDB, so it won't take theft as input. Can you do SMW theft? Yeah. Can you try?
Like this.
Can you do capital?
Okay.
and remove the codes.
Okay.
Yeah. So
This is just for theft.
yeah. So
Okay.
for different years, we can see the count for theft crime.
Okay. So next use case.
Yeah, I'll pass on to Nishal.
Yeah, and go to the main page. So next use case would be yearly analysis of arrests by crime type. So in this use case, we are focusing on evaluating how police presence impacts the crime rates over time. This also helps to understand whether the increased police reduces the crime. Like it's basically to correlate between presence of police and the crime rate in that particular city, like LA or Chicago. So this use case will help us track different categories of crime to understand how often each type of crime occurs in a given year. And it also helps us track how many times each type of crime happens year after year, giving a sense of how crime level changes over time. And also it gives us insights into the arrest data, helping to understand the level of police intervention for those crimes. And also with this use case, you will understand the number of crimes of each type over multiple years and the number of arrests related to each crime type in the similar years, same years. And so how it will be useful is like this will allow policymakers and law enforcement agencies to understand where to allocate their resources, and also it helps them improve their strategies and tackle those situations. And yeah, it could also help them understand make policy adjustments. And if you can go to the code.
Should I just show the function first?
Yeah, you better use for the graph.
Okay. So
Yeah, so we choose the year, and this on the x-axis we have different types of crime plotted against the arrest count in that particular year which we have chosen at the beginning. Yeah,
but
and if you
also
can,
uh,
yep, for different years you find a different data.
yeah.
Yeah, you can go to the code and
Okay.
yeah, same data and tabular format.
So so very simple. Yeah.
Yeah, this is the code. And if you go down, this is a Sparkle query which we are having. So we are using arrest data, crime code, location, year, and if arrested. Yeah, these are the data looks for like particular year 2024. You can see the crime code, arrest data, number of arrests, and all. Yeah, this is the overview of my use case. I'll pass on to Kriti.
Yeah, so the next use case is cross-city benchmarking. So here we are comparing the uh, crimes occurred in LA and Chicago. Basically, we're focusing on crime rate here. So if we go to the UI, click on View Graph. So initially, when we land to this page, it shows all the crimes that has occurred in Chicago and LA. It basically displays the description, like what kind of crimes and how the crime count as well. So when we click on filter it further, so if we go to burglary, so here it shows the comparison between two cities, Chicago and LA, and it shows the number of count, and it differentiates between the crime count here. So in this way, it's easier for people to understand how safe the either of the cities are. So if we go to the code here, this is one of the examples, and if we go to the robbery, so here it's a similar way. We can see the crime count for LA is 4,749 and Chicago is 4,576. So these are basically the comparison between two cities, how the crime rates are. So can you go to the code now? So here, this is what we've written the code for this. And so the query for this here, we'll just run and show. So basically here, we're considering the unique crime code, crime ID, and then go to the show the query.
Yeah.
So here we're linking the unique ID to the crime code. Further, we're comparing that with the city and the crime code. Using this crime code, we're showing the description um, for the crimes. So, so this is basically what we're getting for Chicago and LA. And further, the filtering part we're doing in the React code. So this is what we've implemented in this particular use case. So this is our ontology. So we have created different classes like arrest, city, crime code description, date, description. This is DR number. It's basically code unique ID. Lat means latitude, location, longitude, premise description, victim age, victim descent, victim sex and year. So these things we have here we have created object properties where compared for it's basically comparing the city with the crime code. I mean it's mapping the city and the crime code wherever the crime has occurred and crime city. So this is basically taking the unique crime ID and it's linking with the city wherever that has occurred. Has description, it's basically taking the crime code and giving the description what kind of crime it is. Has latitude dimensions, it's taking the latitude from the location. Has longitude dimension, again it's taking the longitude from the location. Impacted by, basically this gives links the crime code and the arrest status, which is whether the victim has been arrested or not. Link to, this basically links the unique crime ID to the crime code. Link to crime code, basically this is linking again, it's the inverse of the same thing. Occurred on, this is linking the crime to the year whichever it has occurred on. Occurs at, it links with the location. Data properties, we have several data properties. One is has arrest status, basically this is a string value which gives true or false. Has crime code, again it's a string value which is crime code. Description is again a string value which gives the type of crime. Crime number is, this is the unique ID which is DR number. Has latitude and has longitude are decimals which gives the latitude and longitude values. Has name basically is the city name which is again the string value. Occurred in the year, it gives the year value, and date also is the date in which the crime has occurred. So moving on, this is the ontology we created. So after this, we fed this ontology to onto refine. So whatever the data CSV file we had created, we had to split it into different chunks based on the cities. So we created different chunks for Chicago and LA, and just a minute. We created the triples and created the RDF mapping. I'll just upload it and show the triples whatever we created. So this is the mapping we did with the all the tables which is available in the CSV file. So each whatever we showed in the ontology that we have mapped here. Then we converted this to and generated the TTL files which are basically triples. These triples we uploaded in GraphDB. So as I said, we had to create different chunks of the entire data set. So that we uploaded here. We created a repository and then we imported all these triples here. And then we wrote the queries and for our use cases. Ansh, could you continue with the roles and responsibilities?
Yeah. So after this, we had to integrate this with the UI, and for that, we used SparkQuery queries. We integrated it with the React code, and we are facing a small issue with the cost policy over there, but that we managed to resolve it. And Vishal and Prerna can explain their part.
So me and Nishal basically worked on data pre-processing, and also we worked on we helped with generating sparkling queries and also integrating UI and graphic.
So Kalyani and I worked on ontology and working on the auto refine to generate triples. and Ansh worked on integrating and the front end part, which is basically the React part. Thank you.